Hello everyone. Today we'll be studying about basics of object-oriented programming. So, in basics of object-oriented programming, we'll be studying about six topics, that is encapsulation, abstraction, inheritance, polymorphism, data hiding, and message passing. Let us start with encapsulation. What is encapsulation? Encapsulation is the process of combining data and functions that act on within a class. Basically, encapsulation prevents the direct access to data from outside using private access. The data can only be accessed using the private access. It cannot be accessed directly. So the data and the functions are inside the class and can be accessed through objects. Allowed control interaction through public methods. So uh, the interaction to methods is controlled. The data and the methods can only be interact to a controlled interaction, help maintain data integrity and avoids accidental changes. Encapsulation helps maintain the data uh, safe, like data integrity, that data is not changed during the program, and avoids accidental changes. It can only be changed when it is provided the proper access. Next, we will be talking about abstraction. Abstraction, the method of showing only the essential features, hiding the internal complexities. So let us take an example of car. We know how a car starts, but we don't know how the engine actually starts. That is the method of abstraction, that we can see the essential feature that car is starting, but the internal complexities, that how is engine actually starting, is hidden. Keep the user interaction simple and clean. The user only interact with the simple and clean user interface. Achieve using access specifiers and layer function design. So abstraction is achieved using access specifiers and layers function design. Abstraction make code easier to use and less error prone. So using abstraction, the code is easier to use and sometimes reuse and less error prone. So next we will be talking about inheritance. What is inheritance? Enables one class to reuse the another class features. Like we can take a real life example of animal kingdom. So any uh, animal following from a animal kingdom follows the all the features of animal through inheritance. Basically, if we take a dog, it will have also have four lives that an animal will have. So it's like that. So support hierarchical relationship, like animal is to dog, which example we have taken. So allow extension and specialization of code. So using inheritance, the code can be extended and specialized for other uses also. Reduce redundancy and improves maintainability. So the code is easy to maintain using inheritance because we have two different parts. Like one class is performing a work that is used by another class that also require that work. Polymorphism allows the user allows the same function and operators to behave differently. So this polymorphism promotes function overloading and operator overloading so that we can use same function or operator again and again to perform different tasks. Two types of polymorphism are there. Compile time, that is performed during the compilation of a code, that in which a function overloading, which we have talked, is also used. And the second is runtime. So when the code is running, then the virtual functions act as the polymorphism in that code. Promotes flexibility in handling different object types. So basically, in polymorphism, we get flexibility handling different data objects. Simplifies complex decision making code using common interfaces. So the uh, decision making is simplified. Next, we have data hiding. Protects internal object data using private access. So that data is hidden internally, protected internally, and can only be accessed privately. Data is only accessible through public methods. So only a public method can access a data. Prevents unauthorized or accidental modifications. So the data cannot be modified or changed without authorization. Makes programs secure, stable, and easier to debug. So the code is secure, stable, and easier to debug using data hiding. Next, we have message passing. In message passing, objects communicate by invoking each other's method. So, first object will invoke others method, and the other object will invokes first method. So, help achieving modularity and loose coupling. In real world, we use this in sending a message, like sending, receiving, or making a call. You are dialing, and that another person is receiving a call, encouraging just clear logic and object collaboration. So this happens in message passing. What are the benefits of object-oriented programming? There we study the basics of object-oriented programming, four pillars and extra two, that is message passing and data hiding. Now we'll be seeing what are the uses. Reusability, inheritance helps extend existing code. Modularity, code is divided into logical classes. Security, sensitive data is hidden and protected. Maintainability, changes in one class does not affect other class. Real world mapping, programs resemble natural systems.